In drafting workbench, there are a bunch of toolbars that you can see, and we're going to go over them. The major idea is multi-view orthographic projection. So we have created a 3D part like this, and we are going to project that in a perpendicular way to the 6 standard planes, 6 standard surfaces of this glass box, right? Front, rear, top, bottom, left, and right. And since out of the 6, 3 of them are redundant, we're just going to keep 3. Now, as I said, in the US, Canada, UK, we're going to keep front at the center, right on the right side, and top above the front view, and we eliminate rear, left, and bottom. And we call it third angle projection. This is the symbol for third angle projection, and we're going to use this one. Now, so as I said, these 3 views that we keep, we call them standard views. These are the views that we use, and we'll put all the other necessary information like dimensions, tolerances, and so on these views, and then we add more info in what we call a frame and title block, and then we'll send these to the manufacturer. Now, sometimes in addition to these 3 standard views, we also have some non-standard views that can help us show some more details about the part, including section view, detail view, auxiliary view. Isometric view is considered a non-standard view. So although most of the time, as you can see in this course, we do front, right, top, and on this corner we put the isometric view, but isometric is really a redundant non-standard view. All we really need for any manufacturer are these 3. Okay, isometric is just there for better visualization, but the manufacturers, the machinists typically, they have sufficient training in technical drawing that just by looking at the 3 views, they can easily visualize how your part would look like in 3D, but it never hurts if we add the isometric for them. Also, if you remember, we learned in previous lectures that in this technical drawing language, lines are almost everything, right? So each line has a specific meaning. For example, thick line, right? Solid thick line is for visible boundaries, or dash lines for hidden features. Then we have dash dotted line, which is basically used for axis of symmetry, right? If we have thicks at the end, then that is a cutting plane, right? And then we might have short and line breaks with zigzags and basically irregular line or curve like that. There are some more, and then we have thin line, visible thin line, that we use for extensions, lines, dimension line, leaders, hatching lines, and so on. So each one has its own thickness, as you can see, either 0.3 or 0.6. Now, CATIA will take care of creating these lines for us, unlike the people like me back when I was undergrad who did it all on paper and we had to take care of everything, but CATIA does it for you, but it's important for you to know the meaning of each. Now, so first thing is, how can we get into drafting in CATIA? And in this course, we try to stick to the ANSI standard, the American standard. And so we might use ANSI papers, right? And ANSI papers are A, B, C, D, and you can see the relative sizes here, right? So this is the sheet. This is the drafting sheet, as you're going to see. This is what you will see, and all the views are going to go inside it. And here on the bottom right corner, you have the frame and title block. So, as I said, something like this. So now let's talk about first how to create a blank sheet, how to bring these views in, how to add the frame and title block, and then what info will go into the frame and title block. And then we'll go through how to add dimensions, tolerances, and everything else, and create a complete drafting that can be delivered to the manufacturer. So let's get started. So where do we go? First and foremost is, if you want to create a drafting for a 3D object, the file, the CAD file for that 3D object should be also open. So first thing is you go to File, Open, and open up the CAD file from which you want to create or for which you want to create the drafting. Let's say, for example, let's start first very simple. So I want to create a drafting for this member, right? So first, as I said, you have to have the CAD file open. Then you go to Start. Either you can go to New and then say create a drawing for me, or you can go to Start, Mechanical Design, and then go down to Drafting. Okay, either of these. And you get this window. And here, this window will tell you what standard, what paper size, and what is the global scale. If you don't like it, you can click on Modify, right? As I said, we use ANSI standard, so instead of ISO, you change it to ANSI. And then what size of paper do you want, right? A, B, C, D, right? So A is the smallest, D is the biggest. So you choose. Let's say I want a B size. And then do you want to change the global scaling from 1 to 1 to 1 to something else? No, let's keep it. Do you want it portrait or landscape? I say mostly keep it landscape as much as you can. Okay that, and okay. And there we go. We got our blank background paper. And this is where we're going to put all of our drafting. If you don't like this grid in the background, click on the grid and turn it off like that. Okay, so everything should be inside this black window. If anything is outside this window, it is not going to be printed. So the area that you can print is inside this window. Anything outside it is not going to be considered. So that's first thing. Second, how do we get the views in, right? So you bring in this toolbar for views and you click on the very last command. It's called Creation Wizard. And you click on this, and first you specify the arrangement. What arrangement do you want? Of course, we want this arrangement, right? Front at the center, right and top. And these are with respect to the total area of the paper. And the frame and title block here would be on this bottom right corner. So I would move my front, top, and right to this side. And then say next. And here you can add more. Do you want to add like an isometric view? In this course, we try to do it. In this course, unless specified, we are not going to eliminate isometric. Again, isometric is not mandatory, it's a redundant, but we try to do it. So we say, yes, put an isometric for me here. And we don't put isometric right next to the top, front, and right. We put it on the diagonal direction, on the top right side of the three views, and not put it here next to the other views. We put it 1 unit away from them. Okay, and we can move them. I'll show you. When the views come in, we can move them, but we never put them right above the right view or to the right of the top view. Okay, and we finish. And then you expect something to appear here, but nothing happens. Why? Because you have not specified which 3D part you want the views to be created from, but you see this command is still active. So what do you do now? You go back to Window and go to the part that you want to make drafting out of, and then you click on the front plane of that part. You choose the front plane of that part. Now if you come back here, don't click yet. If you just move your mouse from window to window, you can see the preview of these views, right? You also have this compass here, this blue compass, and this blue compass can rotate these views, all of them for you in a specific direction. For example, look, you see this is front, this is top, right? Now if I click on this one, let's see what happens. Look, you see the difference? Now it's like switched. Front is the previous top, top is the previous front. Look at here. I move it back. You see? Because I have rotated the part about one of the planes. Now look at here. Front right, right? Look at here. You see? Now right is the front, front is the right, because I have rotated the part about another axis. Sometimes your part is at angle. For example, it is the front view, but it is tilted. So you can use these two guys and what? Tilt them. You see? Every time it goes 30 degrees up or down. So if you created your 3D part in a way that these three views are not exactly what you want, before you click anywhere, a left click, and fix the views, you can rotate them with the blue compass and fix their orientation the way that is appropriate for you. Then when you're satisfied, you do one left click outside these views and they are fixed now. Okay, so that's the first thing you do. Bring the four views. Now, as I said, everything should be inside this black window. But you see, some of these views are not, and if I add a title block, they might be too close to the title block. So can I move them? Sure. All you need is to drag the boundary of any of these windows, they move. Now, since the center view is always the front view, if you drag the front view, look, everything will move with it. While if you drag the top view, first of all, in order to drag the top view, look, I cannot move it anywhere that I want. All I can do is just go up and down right above the front view. Why? Because these two always have to be vertically aligned. Or right view, look, all I can do is just move it horizontally because these two have to be horizontally aligned. And this guy is only movable diagonally. Okay, so if you want to move all of them, I would say drag the boundaries of the front view. It moves everything with it. Front is the independent. These three guys depend on the front view. Now, for example, maybe you want this guy to be a little further away or a little bit closer to the other three views. Can you move this? Yes. First of all, I absolutely do not recommend you move the right and top view independently. Leave them the way they are. If you want to bring them closer to the front view, that's fine. But never eliminate this alignment. Never move this guy left and right. I'll show you. You can do it if you want, but don't do it. Or this guy, you can move it up and down, but don't do it. Okay? But this one, maybe you want to bring it a little closer. Still diagonal, but maybe a little closer or something. The only one that does not have a 100% alignment is the isometric. It should be diagonal, but what angle of diagonal, it's up to you. So how can I move this independently? Instead of going in this direction, maybe I want to move it just a little bit to the left or a little bit to the right. How can I do that? I right click on that boundary of that view, go down to view positioning, and then said what? Position independently of the reference view, right? Now this guy is independent from that. Look, I can move it anywhere that I want. I can do the same thing with here and here, but again, don't do it. Do not remove the alignment for these three views. This one, that's okay. So let's say I'm now satisfied with my three views, the location of them. And then, of course, we need a frame and title block. So what is frame and title block? What goes in it? I'll show you. But first thing is, let's just add it to see how much space it takes out of my drafting paper. And then I'll show you later how to modify it, okay? So we want to add this title block that basically includes some necessary information. So first of all, how do we add it? Just to know how much room we have left for the four views. So if we go under Insert, right? Do you see anything? Under Views, under Drawing, what do you think? Under Annotation, under Dimensioning, what's your idea? Where do you think I can add that? Should it be under Insert or under Tools, right? So what do you think? If you just search, go down, because you have to insert something, right? So this is for inserting sheet, new view, no. What else? I just want you to be able to find what you might need instead of me just telling you exactly where to go, right? Any of them look like a frame and title block to you? Dimensioning, dimension addition, probably not. For drawing, not. For view, not. So where is that? Do you see anywhere anything says title block? I just want you to see if there is such a thing. No, there is none. Okay. Now, I give you a hint. You go under Edit and click on Sheet Background. When you do that, your background is activated, and your foregrounds, you cannot look. I cannot click on these views and grab them. They go in the background, and the background becomes activated. Just like when you were in part design, remember? When you were in part design, either your part, which is the foreground, is activated, or you clicked on the white lines of the tree and what? Now the part is deactivated, and instead what? The tree is activated. You see, when I zoom in and zoom out, the tree gets bigger or smaller instead of the part, because I'm in the background mode. If I go back to the foreground, now the part gets bigger or smaller. The same thing applies for drawing. For drawing, you either can modify your views or you can modify the background, and frame and title block is a part of the background. So first I said, hey, show me the background. Then what? Now if I go under insert or tools, let's see if you can find anything again. So I go to drawing again. Now look, my menu has changed, right? Last time I was in the foreground, there was nothing under drawing. This time there is, and it's what? Frame and title block. And then it says, okay, what do you want? Do you want to create one? Or do you want to resize one, update one, or so on? Say, yeah, I want to create one. And it says, okay, what do you want? Do you want one of our sample ones that the SALT system made, right? Do you want any of these? So we have some defaults. And I say, yeah, let's take sample one and apply that. And okay, right? Look. And then the frame and title block is created for you, right? Now here you can modify this if you want. This is your time to modify it if you want. We'll do it later, but here you see it says the SALT system. If you double click on this text, now you can change it to ERAU, right? Or this is the name of the creator, me, and the date I have created it, checked by who date, right? So date, I can say this is like 7/18/20. Okay, so I can modify my info. The scale is there. The weight of the part in kilogram is 2 kilograms, and so on and so forth. So this is where you can update. Even you can resize this table. Okay, you can modify some of these lines. You can eliminate some of them. If some of this stuff you don't like, you can just simply what? Eliminate. Whatever you don't like, you would eliminate. There are some places in this table that you might not use at the moment because they are basically for a real company sending it to real manufacturers. For this class that we are doing practice, many of these might not be necessary. Okay, so you might be able to customize your you see here, I should make this guy horizontal. So the goal here is to modify this table, and you see here it does not allow me to do it, but there is a tool, and I'll show you there is the tool that allows me to draw something for myself. Okay, so if I don't want those and I want to modify them, I can do that, right? And you might wonder, where can I draw something here like in sketches? And the answer is yes, you can here. That's your toolbar here. Okay, so if you don't like this, you can just eliminate it and then go ahead and draw a line like this, right? And you can do the same thing here. So feel free to modify this table in any way that you want. And you see here it jumps from grid point to grid point. So if you turn a snap to grid off, then you can arbitrarily click wherever you want. So here we go. Right, so I create my own table, I modify it in any way that I want, and whenever I'm done, whenever I put, and this is the symbol for third angle projection, whenever, and I'll show you later, you have to put notes and other stuff, the name of your part and everything. Whenever you're done with the background, so you have modified your background, where the most important thing is the table, then you go under edit again and go working views. Now you can modify these guys, and if you double click here, nothing happens, right? So remember, background is including table, foreground are the working views, and you can switch between them by going to edit and then going to sheet background or working views, okay? And you can modify each. So now this is a rough first draft of what I'm gonna deliver. Now, sometimes with some of these views, I'm not so happy about their size. I want to resize them. I want to make them bigger or smaller. How can I do that? Well, if you right click on any of these views and then go to properties, here you can see the scaling, right? The scaling for this view is 1 to 1. If I make it 1 to 2, what happens? Look. You see? That gets smaller, but not the other views, because I'm just modifying this guy. Or if I make it 2 to 1, correct, then I can make it a lot bigger. So it depends on what you want to do. For this case, I would say something like 3 to 2, 1.5 could be a nice one. Okay, because I have more room and I need to put some dimensions on later, so there is no reason I make it 1 to 1. I can make it bigger. But you see, I did it for this one, now I have to do it for the other 3. So the question is there a way that I can resize all 4 of them to the same scale all at once and not right-clicking on each one individually and going to properties? Yes. Where? So if you look at the left side, there is this tree. And so drafting environment has a tree just like part design. And under this tree, you can see there are different sheets, and under each sheet, there are different views that you have added to that sheet. So this is pretty much like Excel, okay? There are several sheets. Right now, we only have one sheet, but I'll show you. Let me show you right now, actually. Can I add more sheets? Yes. So under this toolbar here, if you see on the top command, there is this blank sheet. And if you click, there we go. You got what? Your sheet number 2. You see sheet number 2, there is nothing below it. It's empty. Can I move some of these views to sheet number 2? Absolutely. Let me show you that right now as well. So let's say I want to move this view to the sheet 2, although we don't need to, but let's say I want to copy that. So I right click here and say copy or cut, correct? So let's say I want to move it to sheet 2, cut. I come here. Now here, if I right click, I cannot do anything. Okay? So although over there you could right click and cut it, but here you cannot right click and paste. So how do you paste it here? You right click on the sheet under the tree and say paste. Okay? And then you can bring it here. Right? So this is, as I said, like Excel. There are different sheets. Under each sheet you can have individual tables, individual views, and so on. And you will need that later as we talk. When we go to assembly, you need different sheets. Okay? So just showing you how to create sheet and move the stuff. So now let me get that guy back. I don't think I can do it that way, but I can cut, come back here, and paste it back here. Good. So now the question is, I wanted to scale all of these 4 views at once. How can I do that? I right click on this sheet 1, on the sheet, not on the views. Right click on the sheet, go to properties. And here there is a scale for the whole sheet, and I say I want this to be 3:2. And then every view in that sheet will be modified accordingly, right? So you see, I can have sheet 1 with a scale of 3:2, I can have sheet 2 with a scale of 1:1, and so on and so forth. They are independent. So I have resized every one of them to the same scaling, 3:2. Good. So this about this one. We have seen this one. What else? Now you might wonder, is there anything wrong? Is there anything missing here? Especially in the top and right view. Do you see anything missing? Yes, you are right. What is missing? The hidden lines, right? These two holes, I cannot see them here and here. And what else is missing? Center lines. They are missing too. This part has symmetry. I don't see any symmetry line here. So CATIA, when you bring the part in by default, is not going to add for you hidden and center lines. You have to add it yourself. And I'll show you again how to do that. So let's say here on this front view, I don't have center line. So I right click, go to properties, and say what? Add center line or axis of symmetry for me. Or if there is hidden features, add that for me, right? And look, when you do that, you see, now I have a center line here and a center line there for circle. It didn't add the ones for the entire part. Although I clicked, CATIA didn't add that. Can I do it myself? Yes, I'll show you. What about here? Hidden lines missing, center line missing. Can I do that? Yes. I right click, I go to properties and say, hey, add them for me. Look now. Yes, the center line is added and the hidden line is added. And I do the same thing for this one. Yes, center line, hidden lines. Now, you might be tempted to do that for isometric. Absolutely do not do that. Okay, I don't know if I've mentioned it somewhere in the lecture. I should have, but in case I didn't, let's see, modifying views here. Okay, can drag, move, delete, scale, show hidden lines. I don't think I did it at some point, but I don't remember it right now. Never add hidden lines or center lines to the isometric view. Never do that. The isometric view is a redundant view, and we are not supposed to add anything to it. Okay, please keep that in mind. So by no means add ever or add any dimension or anything. Do not add anything to it. Hidden lines, center lines, and any other details to the isometric view. No dimensions, no tolerances, no. The only thing I'll show you that you can add when it's an assembly, you can add balloons for different parts. No other detail. Okay. So let me add that too, just in case. Except for balloons in an assembly drafting. Except for part balloons. Okay, that is okay, but nothing else. Okay, so that is extremely important. Good. So now, in terms of hidden lines, they are good. In terms of center line, they mostly have it, but like here or here, some center lines are missing. Although there is symmetry, CATIA didn't add them. Can we add them manually? Sure. Where is that? I'll show you. So let me show you. As I said, there are a ton of toolbars in this environment. So you see how many I have, and these are for drawing. Let's say for the moment I don't need them, so I'll put them back. Okay, so where is the center lines? They are here, and this is the center line for a circle if it's not added, and then here you have the axis for symmetry. So in case CATIA did not add this for you too, let's say it does, but you can click on this command, click on the circle, and you can create it yourself. Okay, or if it's too long, you can modify it yourself, correct? So you can add them yourself. But for the axis, you click on here, and then you click on the walls of the parts, which gives symmetry. So let's say here I click on this one and this one, right? And you see it didn't add anything for me. If I click here between top and bottom, you see it added the center line here. And then let's see if I can click on this circle and this circle. No, it didn't. You need edges. And this guy does not have edges, so that is going to be an interesting thing by itself. Let's see. Yeah, it doesn't do it. You have to click on straight edges to be able to create a center line in this direction. Okay, so it cannot do that for you. So if you want, you have to create it yourself. Okay, so you have to draw that element. Let's see, I don't have the axis command here. So my best bet is to convert it into a construction element, right? That's something I can do, because as far as I can see, this guy is not allowing me. So I can draw a line like this, and then can I convert it to a construction element? If it allows it to me, that's gonna be nice. Okay, like that. Although construction element is not really an axis of symmetry. Okay, because it's like dash lines, it's not dash dotted lines. So you might neglect that part here because you can do it in the top view. So now, how do I add it in the top view? Why is it that when I click on the center and I click on the left edge and the right edge, why is it that it didn't add a center line here? So I clicked here and here, it didn't take them. Why? Because this view is not the active view. That's another thing you need to learn. If you look at the boundaries, one of them is red, the others are blue. So the red is the active view, is the one that you can add some stuff. Like later I'll show you how to add a section view or auxiliary view or so on. You can only add those non-standard views that you can see here. You can only add them to the active view. If a view is not active or current view, you cannot add many of those details to it. So you might say, can I change this to the active view? Yes, all you need to do is double click on the boundary. Right? So when you double click on the boundary of any view, it goes red and becomes the active view. So now this is active. So now I should be able to create an axis by clicking on these two edges. Let's see. Did it do it for me? Still looks like no, which is again because this is not an edge, this is an arc. This is a specific object that is quite weird. Let's see if I can take the axis of symmetry. Yes. Okay, so you have to take the axis of symmetry. So maybe in this case I can probably do the same thing. This one and this one, yes. Okay, so you see I manually added it myself, and now I can add one here too between these two. Creation of the axis line failed. Here and here, there we go, right? So I can add anything that I want, and I can do the same thing for this view, right? So I can say something between these two is created, and then something between these two, this one and this one. Oh, the command went off. So I can add all of those too. This guy. Didn't take it. This one. That is interesting. The command goes off. So this guy, control this one, access. No. That is another nice one. So sometimes it might be a little challenging. Plus, actually, if you could show it in the two other views, you probably don't need to show it in every single view. Okay, so that's fine. That is fine. So I would say even if you showed it in one of these views, that this part is symmetric about both axes, that should be sufficient for you. Okay, so you don't need to show it in all of them, as long as you show this part has two axes of symmetry. Okay, so I have added my axes, I have added my hidden lines. The sizes are good, right? One of the other things you have are these titles of the views. Right view scale this, top view scale this. Sometimes they are on the way and they're taking too much space, right? So here, this guy, I can move it if I want to, or I can simply what? Delete it. I recommend you delete that. We don't need them because we know which one is front, which one is top, and we know the overall scale from here. So get rid of them. They are not doing anything useful. I would get rid of them personally myself. They don't serve any purpose. Okay, so now I got my views. I scaled them. Everything is good. They are in the good location. I can move them independently and so on and so forth. I showed you how to add a sheet, and you can add a new view to it, or you can cut and paste. So if you want, you can add a new view to it. Instead of cutting something from this view, you can add a new view of the same part in here, right? So let's say I want to add the isometric here or another view here, so I can do that, right? Or a section view, which I'll show you later, but let's say you want to add a view here, as I said. So this command, remember, this gives you a new sheet. This one gives you a new view. And if I go here and I select this guy, okay, oh no, not that one, actually here, this guy. Let's say I want an isometric of that part, correct? And I choose it and come back, and I can add that to sheet 2, right? So I can add new views using this command, or I can just copy and paste from one sheet to another. Now, one thing that is important is updates. So sometimes you go and update your part. So when you update your part, and when you go back to drafting, do you need to redo the drafting because the part has changed, or can you just update and the drafting would change accordingly? And the answer is yes. You never need to start from scratch again. So here, let's change something. Let's, for example, make this member longer, right? And change this whole diameter, make it like 8, and also change this guy, make it 12, right? So I changed the parts completely. It's a different part now. I'll save it for a moment, and when I go back to the drafting, all I need is to click on update. Yes, I do not need to start from scratch here. Updating will update the drafting based on the changes in the part. That's all you need to do. So can I change this back? No. Go back to 60 maybe. It's too long. Let's keep it this way. Good. And this is interesting. You see one hole is different than the other. So here you don't have symmetry. You have to be careful. Yes. Right? Not both of these are the same. When you say symmetry, you really have to have symmetry on both sides. If one of these holes is not the same as the other, you don't have symmetry. So be careful. Okay, now you have symmetry. Okay, so I showed you how to do update, add a view, copy or cut, add center lines. I showed you that. Now is the time for the next major thing, adding dimensions. Okay, and for dimensions there are rules. You don't just go randomly and arbitrarily put any dimension you want anywhere that you want. Okay, there are some, you have some choice, but not everything is arbitrary. So there are two types of dimensions that you can create, linear and radial. Right? So for linear dimensions, there are some important things and some important terminologies. So first, if you look, each dimension should always be placed outside the drafting view. You never ever put any of these dimensions inside the view. You always put them outside, and I mentioned that in one of the future slides. That's one. Now, when you do it outside, you need this extension line. So these two lines that extend the edges, we call them extension lines. This double arrow is dimension line, that is dimension text, right? So dimension text, dimension line, extension line. Just knowing the name of these guys, which I mentioned here for you. So first, again, and as I said, these are mentioned down here in good dimensioning practices, right? Put everything inside, never do more than one, and so on. So I basically summarize them for you here, but I'm telling you one by one as we go forward. So first important rule, never put any dimension inside. 2, for each feature, only mention the required dimension once, not twice. For example, in here, I mentioned the overall width of the part, and I mentioned the width of this first part. Do I also need to mention the width of the second part? Say, hey, this is 1.5. No. Never add a redundant dimensions. This is 1, that's 2.5, this is 1.5, of course. Do not add, right? Or this whole thing is 1.5 the height, this is 1, so the height of this small part is 0.5. Do not add that, okay? That's extremely important to avoid redundant dimensions. That's rule number 2. Then, when you want to provide the distances or gaps of different features, there are 2 ways that you can do it. One is called the stacked method, the other one is called chain method. In the stacked method, you provide the distances of different features, different entities, all with respect to the same reference. You see here the distance between this wall, and this wall, all given with respect to the left wall. So this is called stacked method. In chain method, every feature is referred to the previous feature. So this is with respect to left, this is with respect to the second wall. Now you might ask, why didn't we provide the distance between the last wall and this third wall? Why didn't we do that? And that is another rule. When you do chain method, which is this guy, you always leave the last part of the chain off. Instead, you show what? The total length of the chain. So you show the total length of the chain and you leave the last part off. Why? I'll show you later when we go to tolerances. Why is it that we do it this way for the chain method? Okay, so this is very important. In chain method, leave the last portion of the chain off and show the total length. And I guess again in this good practices, I guess I mentioned it. Let's see. only dimension object feature once. I said that. Common mistake to applying all views showing okay. Dimensions should never cross. Shorter dimensions should be placed closer. Only dimension location sunlight not to curves. No, actually I forgot to say that. So one, place all dimensions inside outside the views only. Then never mention something more than once. The other thing is in the chain method, leave off the last part of the chain and instead show the entire length of the chain. Okay, this is very important. Okay, let me get rid of that for you. Okay, so we'll try to make sure everything I say is mentioned in this slide for you. So we mentioned that about the chain method. Another important thing is the dimension lines, which are the double crosses, should not intersect each other. So in here, if instead of this 15 being closer to the object and 25 being further away, I move them. So bring 15 outside, bring 25 inside, then the dimensions lines and the extension lines actually cross, not the dimension lines themselves. And that is not a big error, but try to avoid that. So let me show you over here for this part. First of all, how do we add views? So to add views, we bring in the dimensions, we bring in the dimension toolbar, and the top command is for creating all sorts of dimensions. This is the smart version, but if you expand it, you have different things for different features. So for example, for chamfer, for diameter only, radius, angle, stack method, chain method, and everything we have. This one is the smart one. So this tries to use any of those based on the feature. So I typically go with this in the beginning. And let's say here, I want the height of the part, right? So I go in this view and click on this edge and click on this edge and bring out the height. So that is the height of the part, yes. And then I need to provide diameter of this hole. So I click here, I click on the hole and provide diameter, and then I do it like this. So what's wrong here? This dimension line and that dimension line are crossing. That is wrong. That should not be done. That is a big error, okay? So never do this. Never should two dimension lines cross. Now sometimes a dimension line and an extension line might cross each other, okay? And I'll show you that. Try to avoid that as well if you can, but that's not a huge error. So let's say here I provide the length of the object, the width of the object, and then that's an error. Don't do this, but let's say I show the diameter here and I bring it further away. So I put the bigger dimensions closer, the smaller dimensions further away from the view. What happens here? These two extension lines are intersecting with the dimension line. That is not an error, but we try to avoid it. By what? By bringing the big dimension further away and the small dimension closer. Okay? So try to avoid this if you can. But two dimension lines like this for sure should not cross. So you should move your radial dimensions so that they don't cross the linear dimensions, okay? So that is extremely important. Now, Uh, so these are some, so far, some 3 important rules or 4 important rules. And I mentioned the chain method. Now, let's talk about some rules for radial dimensions, and then we talk about further info that you need. So 1, as I said, radial should also be placed outside so that they don't intersect with linear dimensions. Then, if it's an entire circle, if it's a full circle, you always show diameter, and diameter is shown by letter phi, Greek letter phi. If, on the other hand, it is an arc, it's not a full circle, you never show diameter, you always show what? Radius. Do you see the important point? Full circles, always diameter. Non-fulls, arcs, always radius. You can never do otherwise. I've seen this a ton. That my students use this guy, they use radius for it. Okay, so they come and apply a radius to this full circle. This is wrong. This is a full circle, you never do radius. Or for this arc here, or this arc, semicircle, they use diameter. They say, hey, I want the diameter of this. Don't do that. These are wrong. Okay, never ever do that. If it's a full circle, you apply a diameter. If it's an arc, you apply a radius. That's how it should be done. If you use your smart dimensioning command, it knows this rule. So if you apply it here, oh, no, it doesn't. I take my word back. Sorry, sometimes it goes a little bit stupid. If it does that, then try to eliminate it. It used to know, I don't know what happens now, it is acting a little stupid. So it knows this is radius, but I don't know why it assumed this is a diameter. I mean, when I clicked on this, it knew its diameter, you see? Why is it that when I clicked here, that is very weird. Yeah, it is saying it's radius. It's acting differently. So if it happens, don't take it from him. Say, no, you don't know it. I use the diameter tool myself and do it. Okay, so that's another important rule. So I guess I mentioned that for you here as well. I mentioned it in this slide, but I can add it to the main slide. Let me put all of them in one place. Use diameter for a complete circle and radius for an arc. So that is very, very important. Okay, one more important rule about radial dimensions. So if we go back to here, so if you look at this part, this is the front and this is the top view. So if you look at this cylinder, the big cylinder, the extrude with diameter 1.5, I could show that diameter either here or on this top view. Which one do I choose? You see here it shows the front view. Or the diameter of this hole, this cut extrude, I could show it under here, or I could show it here on this hidden lines. Which one did it choose? It chose the top view. So sometimes, most of the times actually, you can provide the dimensions of some feature either on one view or another view. Which view do you choose? So for the case of cylinders or cylindrical cuts, there is a rule. There is a rule. If it's a solid cylinder, it's an extrude, you provide diameter in which view? In the view that the cylinder appears as what? A rectangle, the side view. On the other hand, if it's a cut extrude, a hole, you show the diameter on the view that the hollow cylinder appears as a what? Circle. To what? To avoid putting dimensions on hidden lines. That's another big rule in CATIA, not in CATIA, I'm sorry, in technical drawing, that place dimensions outside the views. Let me add that. Try to avoid putting dimensions on hidden lines. Always try to, as much as you can, try to put the dimensions on visible lines, not on hidden lines, okay? So that is a very important thing. So let me add this rule for you here too. For a solid cylinder, show the diameter where it appears as a rectangle, while for a hollow cylinder, show it where it appears as a circle. Okay, this is another important rule that we try to do. And here I'll show you later, section views can help. And I'll tell you what I mean by that. Okay, so I'm just putting everything in slide 34 for you. So did you get the point? Holes where it's circle, solid objects when it's a rectangle. So if I go back here and apply it to our case, right, the diameter of this hole, should I show it here in the front view or in the top view or in the right view? If you see in the top or right, they appear as rectangle while it's hollow, and I have to show it on hidden lines. But here it appears as a circle and they are visible, so I show it here. So never show the diameter here or here, right? That's another important thing. Good. So I guess I mentioned the important rules about radial. Now, there is one more point here. I want to clarify it before we go to basically more details. So, and that is this guy. It says for curved surfaces, only dimension location to the center of the line. That is very, very, very important. So many times I have seen my students, like they want to provide the distance between the circle to the center of the part, right? So what they do, they provide the distance between the right side of the circle to the center line instead of showing the center of the circle to the center line. Never provide the dimension or the offset to the edges or the non-center points of an arc. If there is an arc or a round or curved surface, always show the center of them with respect to something, never their left, right, top or bottom points or edges to something, okay? So here, if you want to provide this offset, which you should, if I click on this circle and then click on this edge, you see, this is the distance to the center. I can change it to be to the right side, but I don't. So these are important. Or if you want, you can here, since I have added the center lines, I can use the center line between this one and this one. I can do that. Okay, so it is very vital, very important to do that. Okay, so I mentioned these important rules. Now, first, let's go and complete that example that we started, and then I need to talk about the font size, the units, and the precision, which are really important. So if you look here, first of all, the units here are in feet. Well, I designed my part with inches, not with feet, but here the unit is in feet. How can I change that? If you see here on the top, there is this toolbar, and this is for numerical properties. So the units you see is feet, but if I can go, I can change it to what? To inches. You see that? Right? And if I want, I can change these guys too. I multi-select them and change everything to what? To inches. Right? Or if you want, you can change them to millimeters if you want, right? You can, because I guess I made it actually with millimeters. So let's say I want these all in millimeters. Yes, this is what I did. So although it is ANSI standard, you are not forced to make all of these dimensions in inches. If you made your part with millimeters and you're only doing your drafting in ANSI standard, you can still use millimeters, because these numbers makes more sense with what I inputted here, right? If you look, I used 10 and I used 60 and so on. I didn't type in the number in feet. So you can change the units of your dimensions. That's one important thing. The other important thing is sometimes your dimensions have decimals. So for example, if I change this guy to inches, you see this guy has decimals, of course. And sometimes you need more decimals. And I'll show you later why. It's when you add tolerances, and your tolerance have 3 decimals or 4 decimals, so your dimension should also have 3 or 4 decimals. So how can I change this instead of 2 to be 4 decimals? I go to this guy here on the right side, precision. And then I say instead of 2, go to what? 3 or 4, right? So it can give me more decimals. So this numerical properties toolbar is very important in changing the units and changing the number of decimals. Okay, this is extremely important. Try to take advantage of this. Okay, so this about this one. Then the other thing important is the font size. Sometimes the font size of these guys is too small, right? So if I don't zoom in, you can barely see these numbers. They are too small. Can I make these numbers a little bigger? Yes. How? If I click on this number, then I can see this guy here up there for the font. Not only I can make them italic, bold, change the type of the font and the size of the font, right? So here, say instead of 3.5, make it 7. Then I can change this one and so on and so forth. And you might wonder, hey, should I do it for each and every one of them? I go or I multi-select, right? I can multi-select, select this one, and then change both of them together. But the problem is when I go to create another dimension, let me show you. When I go to create another dimension, like the depth of the part, the thickness, again, it goes back to 3.5. So I have to change that as well. So changing the font size for one dimension or several dimensions does not change this number for future dimensions. For future dimensions, again, it goes back to this default 3.5. So whatever future dimension you make, you have to again come back and change it. Or somebody might ask, hey, is there a way that, let's see, where was it? Is there a way that I can change the default font size? And the answer is yes, you can. Let me just find it where it was. Yeah, here. Changing dimensions, font size, okay? You have to go to options. If you go to options, you can change the default font size so that it doesn't keep going back to the number. Where is that? It is mentioning for you here. It is under Mechanical Design, Drafting, Administration tab. Okay, so you go to Tools. Let me get rid of this. Tools, Options. Then you go to Mechanical Design, Drafting. And there are a ton of tools. You go to the very right to the Administration tab. Right? You see here? and then under style you say configure, and here you see font size. It's based on the style and the standard. You can change it to be what? A fixed value instead. And now if you come back, now when I want to provide a dimension here, it is asking me, hey, what number do you want? I say I want font 7, and I enter. And I do it, yes. Now, actually wait. I click here. Before clicking anywhere, I change this number first to 7. Now I provide my dimension. Now look, it did not go back to 3.5 again. If I provide another dimension, it is gonna stay at 7, and from this point on it is not gonna change. Yes, so you see the importance of, if you want, you can change the font size to be of a size that you want, and it doesn't go back to the default small number. Okay, so changing the default font size is actually a very good tool. It can save you some time. Very well. Okay, I'll talk about auto dimension tool later and balloons. Let me practice a few things with you, and then we do some exercises. So one is, what's wrong here? Clearly you see crossing, right? 2-dimension lines are crossing. That's a bad experience. And what about here? Do you see anything wrong? Yes. A dimension is left inside the view. And any other thing that might be missing? Yes, that's another one. Multiple features that we have to talk about. A dimension that is the same is provided twice. And I guess the rest of it looks relatively okay to me. So these are just some exercises. Now let's go back here, first complete this. So what do we need to do? Whenever you create a part and you want to make the drafting, first thing is make the size appropriate. Second is make sure the hidden lines and center lines are shown. Third is you show the overall dimensions first. What do I mean? Show the overall width, the overall height, and the overall depth. Okay, these are the most important thing. So here for this part I have shown the overall depth and the overall height. That's good. Now do you see anything problematic here? Yes. What is it? When this radius is 12 and this is a tangent arc to both of these guys, when this radius is 12, of course the diameter is 25, which is the gap between these two lines. So should I provide both of these? No. One is redundant, so I can eliminate that. So avoid redundance. That's one. So with this R of 12 here, I know the overall height is 24. The depth is given. What about the width of the part? So instead of this, I can provide what? If I click on this arc and this arc, you see, I can provide center to center. And that would tell me the overall length of the part, right? Because I know the center to center, and this is 12 extra and this is 12 extra. So the overall thing is 84, right? Instead of providing what? The end of the arc to end of the arc, which I said you should avoid, I provide what? Center to center. Do not go right edge of this arc to left edge of that arc. That's not a good way to provide. So now I have the overall height, the overall length or width, and the overall depth. Now about a feature like a circle or a hole. When you have a circle or a hole, not only you have to provide the size, the two other very important thing that always my students, many of them forget, is the location of the center. Where is the center? Like, for example, where is the center with respect to the center of the part? Now, should I provide this dimension and say, hey, the distance between this one and this one is also what? 30. Do I need to do that? First of all, you see, it gives me the wrong dimension and say, hey, this is 60, which is not, it is 30. So it is confused a little bit, actually. It is confused a little bit. And you should not do that. Why is it? Because I have this symmetry. And when I have the symmetry, it means this distance is the same as this one. So this left distance and right center to center of the part, they are the same. And the whole thing is 60, so each one is what? 30. So even if you provide 30, that's redundant. Don't do that. Then where is the where is the y position? So that's the x position with respect to the center. Where's the y position? Again, since the centers are on what? This other symmetry line, it means their y, if you put the origin here, their y is 0. So they are horizontally aligned with the center of the part. So in this case, this is a simple example, and just this 60 will provide everything I need. Now, since this part is symmetric, it means that this guy is also what? 8, because this is symmetric part. One thing you can do is, in this case you don't need it, but when you have several of the same feature, like you have several of the circle all around the object, we call it multiple features, and I mentioned it here. When you have several of the same feature, you're not going to show, let's say, several holes. You're not going to show the diameter on each one separately. So here I have what? Here I have 10 circles. I'm not going to show on each one of them, hey, phi is this much, phi is this much, phi is this much. No. I only show it on one of them, and then I use what? I use n times, okay? I say I have 2 times that diameter, means I have 2 of those. Or I can use the word TYP, which is typical. So here, again, in this case, you don't need to because you have symmetry, but if there was no symmetry, I can say, hey, this is 2 times phi 8, which means I have 2 of this feature. How can I do that? How can I add that 2 times phi of 8? I right-click on this, go to Properties, and then go to Dimension Text. Okay, go to Dimension Text, and here around this main value I can write on the left of it, above it, below it, and to the right of it. And on the left I say what? 2 times, and look, yes, I have 2 of that feature with that size, and that's it. That's how you show a multiple feature. Now, another way, as I said, to do it is, instead of this, on the right side, right, you can say TYP. Hey, this guy is a typical. This Y is a typical. If you see another circle on this part, this is the diameter for all of them. This is a typical diameter. Okay? Now, I personally prefer this n times instead of typical. Why? Because typical does not tell you how many of that feature you would see. But n times would tell you how many of that you should expect. So my preference is n times instead of typical. Okay, so I prefer to say 2 times, not typical. The other important thing is, some of my students, they put this 2 times on the right side instead of left. They say this, phi 8 2 times. They do it like this. This is wrong. Don't do that. 2 times what? If it's 2 times something, that something should be on the right side, not on the left side of the 2 times. So always put this on the left side of your text. Okay, this is how you do it. So this is the way to show multiple features. n times, 10 times, 5 times, and to the left side. Okay, and again, I try to avoid TYP, but it's another way some people use it. Again, in this case, since the part is symmetric, it's not mandatory to add that. So now, is there anything else I need to add to this drafting? So I had a major part, I provided the width, the height, and the depth. I have provided the diameter of the circles. I have provided the location of them with respect to the center. And that's all this part has. It's not a complicated part. It's just, and I provided, of course, the radius of each arc. And it's symmetric. Now, again, this is like what? I have one here and one here. So for this one, I can say what again? 2 times, right? Because this is repeating itself in 2 places. Again, because of symmetry, I don't have to do it here, but it's a good practice to learn it. So that's it. That's all I need for this part. And now some of you might wonder, okay, I only used the front and the top view to provide dimensions. Do I need this right view really? This is so simple of a part. With this view and that view, I can easily imagine, and plus the isometric is there. Can I eliminate this and send it to the manufacturer? Yes. In this case, actually, you don't need this, you don't need that. That's all you need. Because this is too simple of a part. So if you see draftings with only a few views, 1 or 2, like, where was it? The slide that I showed you. Look at there, right? Only front and right. There is no top view. And there is no isometric. If you see that, don't be surprised. Some parts are too simple. Only a few views are enough. You don't need a ton of views. Some of them are redundant. Many people would eliminate them. That is fine. But in our course, just for the sake of learning, please pay attention. In our course, for the sake of learning, even if they are redundant, do not eliminate them. So as long as you are in this course, do not eliminate any of these 4 views, even though they might be not exactly informative, right? Redundant, they are redundant. That is fine. Don't eliminate them. Good? Excellent. So in this simple part, I could easily create the drafting. I provided the dimensions. We'll talk about tolerances later. Is there anything else I need to do? Yes. I need to go back to my table and edit it with some information. Like what? Many times I ask you to provide the mass of the part on this table. By the way, what info should go in this table? We skipped that, so now we have time to go back to it. What info should we provide in the title block? So the title block has a bunch of info. One is the name of your parts, or the name of the originating company. The name of the title, as I said, which is the name of the part. The name of the company. Drawing number. Many times you organize your document by providing numbers, right? Like a dissertation or a book has page numbers. Drawings also do, because you have too many drawings for a big part, a big machine. Revision numbers, many times the first time you create a drafting, it's not going to go to the manufacturer right off the bat. There is typically a supervisor which will check your drafting and revise it, or maybe you change your design and now your drafting have to be updated. So many times there are revisions, and you have to show this drafting belongs to which revision, and then approval of your supervisor. Okay, without his or her approval, you mostly, as a rookie that is just going somewhere, are not going to send the stuff to the manufacturer. It happened to me myself. I was a PhD student and I was working when I was back there at Oklahoma State for a company that was affiliated with our university, and I was creating CADs, and I was relatively good with CAD and knew what I'm doing, but when I created the drafting, there was the lady that was my supervisor, and she was an experienced person in the area. And every time my drafting should have been gone to her, and she could have made some red marks and say, hey, modify this, change that, show this, don't show that. So that when it's sent to the manufacturer, that is completely clear and meaningful. Because if it's not, if your drafting has a bunch of flaws, the manufacturer is not going to clean it for you and make the part. They just send it back to you and say, hey, this is not right. Fix it and change it back. And that going back and forth will take a couple of weeks, or a week or so, or several days. And you know what that means, right? Wasted time means wasted money, and that is not going to be good. So the companies won't allow that when you're going and joining somewhere. It doesn't even matter that maybe your degree is higher than your supervisor. My supervisor had a bachelor degree, I was a PhD student, but she had a ton more experience than I did. So she would always have checked my drafting. So you need the approval. And then you need the scale for your drawings, maybe the size of the paper, the sheet number, weight, that is very vital. Why? Because those people who would manufacture it, the first thing is they want to know with how big of a part they are dealing, right? Is this part that you're sending to them to be manufactured is a ton or 2 kilograms or 100 kilograms? Can they lift it? Can they handle it? Or they need a special equipment to move it around? And then additional info like the material, a general tolerance, general dimension note, heat treatment, finish, and so on and so forth. So this info should go in the title block. The name of you, the title of the drawing, the weight, a general note, and so on and so forth. You have to put them in the title block. And we want to do that right now. Okay, we want to do that and make sure whatever we're printing is going to be with sufficient info. So first thing is, if I go back here, this guy does not have material. Let me just go ahead and apply something to it. Let's say aluminum, and apply it to this part. Right, so the material is aluminum, and then I measure the mass of this guy, which is 48.56 gram. 48.56, right? So now when I go here, I want to edit my title block. So I go to edit, go to background, and then I come here. So first I would add a what? Name. This is the name of the originating company, ERAU, EGR 200 or whatever. Then this is the name of the part, so I can call it sample 1 or anything you want, right? And then I can provide note, a general note here somewhere that would tell the user about the material and so on. So you see here, there is a weight in kilogram. So this one was 40 something, right? Let's change this. Let's see if I can modify this guy. So it was 0.045 kilogram or so, correct? So I can put that here and put this scale back. You can change the font size or anything to put them back to where they belong. Okay, so if 32. Yes. Okay. Let's see. Yeah, this. When you move them from their original location, it is not going to be super friendly to put them back. But what you can do is, let's say here, now in this case I don't need checked by anybody, so I can get rid of them, right? And oh, okay. Let me see if I can grab the whole thing. That's once. Bring it all here. Bring this. You see, that's what I said. When you move them around, they become a little less friendly. Maybe this, and then that's okay. Can get rid of this. Let's put this here. That can be the weight. Even if I want, I can go here, use this text tool, and then say here this is like the mass. That's another big thing that I don't like, that CATIA calls that weight. That's not weight, that's mass. Okay, weight is in newtons, mass is in kilogram. So that is a very bad error that happens, and I totally dislike it, to be honest with you. Never please write such a thing in your drafting. Never say that the weight of the part is 2 kilograms. That's not good. Okay, that undermines our knowledge of engineering. Say, do you mean what? Do you mean that was the mass because it was in kilogram? What do you mean? So please make sure. So here, that is mass. This can be material. And okay, that. You see, it takes a little time and patience if you want to update your table. And this can be scale, and this can be size, right? So feel free to modify it any way that you want, and I can probably shift this guy up and then shift this one up and bring this here. It's quite interesting, these two seems to be linked. Okay, and then design by here, that's my name is enough, I don't need the company really here. And drawing number, you see there are too much of space here and there that I do not need. So sheet 1-1, then I can have something here and then something down there, right? So this is going to be like company. This is going to be drawing title. And this is going to be like notes, which is always important. And I'll talk about this. Okay, and so now you can say this is ERAU. And then bring one down here, copy. If this is too much room, you can modify it. Okay, feel free to modify this table, and I'll tell you, we have one that is already available and you can use that if you want to. You don't need to, you're not limited to this guy necessarily. So I can go ahead and here limit this. Okay, and then bring this guy up. That guy down. Okay, so as I said, this can be sample 1 or session 1 or something. And here, as I said, this is going to be notes. And in notes, you say all dimensions are in millimeter and tolerances are some stuff which we'll see in the next lecture, unless otherwise specified. So whenever I say provide a general note, that's what I mean. Alright, goes to the next line. And this is too big. So you see, all dimensions are in millimeters, right? And then I can say all tolerances are plus minus 0.01 or something. As I said, we're going to talk about them in the next lecture, how to specify tolerances. Correct? And then we can add one more of this line here. And tolerances are something unless otherwise specified. Okay, and again, if this is too big, change the font size to something else. Okay, and then you can come here, then say, hey, size is E, right? And bring these guys back, bring this guy back, add maybe one more down here if it allows. Oh. Correct? Or maybe, yeah, as I said, modifying these needs a little bit of patience. Maybe you can just say B for this case. It's paper size B. Then the scale is 3:2. And then mass is 0.045 kilogram. And if this is too big, feel free to change it. Right? This is, as I said, not so user-friendly. And then for material, you can add one more if it allows me to bring it here. And here you say aluminum. And again, you can change the size. So just modifying this table can be quite time consuming and painful sometimes, but if you get it all right like this and you're happy with it, then go edit to working views back. So now you have some nice thing, and then this is ready to be printed. So you go to file and print, and here you don't need to print any of these tree or anything. So you go to file and then you go to print, right? And you choose a printer, and then preferably make sure it is going with landscape print, and then fit it to the page. So print it as big as possible so that it shows all the fonts big enough. And when you print this, it is not going to print the boundaries of the views. Okay, so don't be concerned about that. It is not going to print these red and blue boundaries. They're just for visualization here. So it is going to turn out nicely. Yes? So this is how you get started on a simple drafting. Okay, so I guess I mentioned the important stuff for you. Again, summary of good dimensioning practices is in slide 34. We're going to do this practice and a lot more than that in the classroom. There are some other small details that I need to tell you. Although those summaries are here too. Not curved edges. I guess I mentioned these. So what I can do is I'll bring this slide to the very end of my lecture. This guy. Bring it down here. Right, place all dimensions outside. Not putting ones in the chain method. Do this. In this tagged method, place shorter dimensions closer to the object. Yeah, this is good. So I don't need these guys. I mentioned them. So I made it the last slide of your lecture so that you can always refer back to it. What else do we need to know? So let me also bring these guys to the very end. I'm just trying to make it more user-friendly for you. So if you have holes, several holes in the object, as I said, you always need to provide the X and Y location for the center of the hole in addition to the diameter. Okay, and if there is something that is repeated, right, there is a pattern, you can take advantage of that pattern. Now, if it's not a simple hole, it's a machine hole. You can show the depth of the machine hole either on the side view, where the hole appears as what? As basically hidden lines, or in order to avoid putting the depth on the hidden line, there are two alternative ways, which I always recommend using this. Either use the depth symbol, which I'll show you, and put it next to the diameter. So in one leader, provide not only the diameter, also the depth of the hole. And I'll show you how to do that. Or use a section view. We'll do it in the next lecture, but if you use a section view, then these hidden lines will be visible. So cut this object with the plane that passes through the center of the hole, then the half of the hole will be visible, these lines will be visible, then you can put the depth on those visible lines. So as I said, you can use section view, which we'll see in the next lecture. Alternative to that is using the depth on the diameter at the same time. So here, for example, look at these two holes. They don't have a specific depth. They are what? True holes, right? So these holes are all the way through the object. Can I specify that here? Yes, I right click here, go to properties, and then on the right side I use THRU. I don't write the whole word, I just say THRU. That means these holes are both what? Through the object. They are through all, through last. Okay, so I can specify that here. Now, if they were not all the way in and they only had some depth, right? So let's say here, for example, these holes were not exactly like that. I could go here and either use the hole command or use the cut extrude command. And, oh, sorry. Create them. So here, make this like 8 and then do the same thing here. 8. Oh, sorry. And then make sure the gaps are observed. So this one was 30, I assume, and this one was also 30. And then I don't cut them. Something is what is it? Yeah, that's the problem here. You see, this 30 is not measured from the center of the hole to the y-axis. Is measured from the right point. That is a bad dimension. Don't ever use that. Make sure you select the center to the center. Okay, so that is important. And then you get out and then cut it. Instead of 10 units, cut it 5 units. Okay, so they are not. Oh, it's 5 units. I thought it's 10 for some reason. It is 10. So what happened here? Is it true last? Yeah, that's the problem. Here. Okay, so they are not completely hollow. I'll save this, go back here and update. So now you see, I have some depth I have to provide, so they are not true anymore, so I have to modify this. Instead of true, I have to say so much of depth. Now this depth symbol that you see here, I can provide it. The problem is, when I go here and change my symbol for this dimension from diameter to what? To the depth symbol, which is this guy, right? That's the problem. The diameter goes away. If I go and change it back to diameter, I cannot show the depth. So the problem is in CATIA, you cannot show two symbols in one text dimension. You can only show one of them, either phi or depth. So since here the phi matters, I use phi. And you might wonder, okay, then how can you show this depth symbol? I don't. Instead, I type. And I say what? 5 mil depth. And I use a comma in between, like this. Or I use deep, actually, not depth. I use the word deep instead of depth. 5 mil deep. Okay? So now I have provided what? The depth here. Instead of showing the depth like this, between this one and this one, instead of showing it this way, correct? I can do it here. But then I'm showing it on invisible lines. I don't want to do that, so I show it on the diameter dimension text. So that is the better option. So this is about machine holes. Now, what if you have threads? Where is the thread? I had something about the thread too, I guess. Or no, but I can show you what happens when there is a thread. So if these guys are threaded, then what happens? Let me show you that. So here I make this part a little thicker. I make it like 20 mil. And then instead of these pockets, I use the hole command, and I provide a hole here with diameter of 8, a depth of 10. Type I can leave it as simple, and then I thread this. Okay, and I make it metric 10 pitch. Going to be M8-1. Of course, you cannot have 8. That's another thing. If your hole is 8, your thread major diameter cannot be 8. It has to be what? Bigger than 8, right? You cannot drill a size 8 into something and then use a bolt with diameter 8 in it, because you always need to leave a little bit room off to cut the threads inside the object, to tap the object. Okay, so you cannot here come and say, hey, you see, it modified accordingly itself. If you choose an M8-1 thread, which means major diameter 8 mil and 1 mil to be the pitch, it says then the whole diameter is not going to be 8 anymore. It is going to be 6.917. This is the standard drill size that you need if you want an M8 thread to be created. Where did CATIA get this? From standard tap drill size charts, and I've got them for you and added them to our Canvas under modules. If you go to Canvas under modules, I added something for you. If you go under tutorials, you see I added 2 things for you, or 3 actually. This is for tolerance for next lecture, but these 2, tap drill size chart metric, imperial metric pipe tap. So these are for metric threads, these are for imperial threads. So if you click on these guys, these are standard tables which would tell you basically, depending on the major diameter of your thread, which comes right after letter M, then what is your drill size? You see that? So when you go M8-1, this is almost your drill size, 7 mil. Okay? Yes? Depending on what you want to do, but here, this is with more decimals accurate, so that is rounded, 6917. So that's how much you should drill. And then you can position it, of course, and say, hey, I want this center to be exactly 12 from the top and bottom. and then I need it to also be at the center of, or this is what I can do instead. I want this point to be the center of that arc. Let's see if it allows me to apply a geometric constraint by concentricity. Yes. So I put this guy at the center of that arc, which is exactly where I wanted it to be. And I OK that. Yes, so now this is a drilled machine with a thread. Again, thread is cosmetic. This is not actual thread. It is a cosmetic thread. I can apply thread analysis and see there is thread. Another way to see thread, as I mentioned, is in the whole symbol you see a 3/4 circle. That means there is thread here. And I mentioned earlier that also in drafting you can see there is thread, and I'll show you right now. So let me repeat that here. So what I want to do is I want to repeat this guy. And I want it along this edge, and I want the distance to be, I guess it was 60 mil, wasn't it? Yes. Good. So now I got myself both holes threaded, not all the way inside, and I save this. And now I go back to my drafting and update, and look what happens. So here, first of all, you see the threads are added. Really? I don't see any thread. Where is that? I can see the hole, and this is the end of the drill bit. This guy here, that's the end of the drill bit, but I don't see anything extra to show me there is drill. There is a thread, I'm sorry. Why? Because I didn't add it. You're right. I need to add, and I don't see anything here or here. So this is what I need to do. I right click on them, go to properties, and I should also activate the one says show me threads. And the same here. And the same here. Now what has changed? Look. Now there are two lines. The first line, the inner line, is the drill. The second line is for major diameter of the thread. So these double lines now would tell you this guy is threaded. And they can also tell you how far the thread is. So here the thread is gone all the way to the end of the hole. Sometimes it's not all the way threaded to the end of the hole, right? So if I go back here and click on this hole guy and say here, you see the thread depth is 10 and the depth hole is also 10. So let's make the hole a little deeper, right? And go back. Most of the time what you have is something like this. Okay, so if you see this symbol, it means what? This is the thread, this outer lines and edges, and this guy is your hole. And then in the front view, you can also see that. There is what? An extra hidden line circle, which is for major diameter of the thread. So using this guy, or using this guy, you can see that this hole is threaded. So here, now there is depth, and this depth is how much? It is 12 mil, right? So it is 12 mil depth here. Yeah. So that's how you should do it. Good. So I have provided this. Then let's see. Whole dimension table, coordinate dimension table. No. What was this? Is it the thread? Yeah. This tool is for thread dimension. So if you click here and then click on this arc here, it provides what for you? Yes, the thread. So if you ever create a thread on a hole, not only you have to provide the specs of the hole, right? Correct? You also need to provide what? The specs for the thread. So in this case, you don't need to provide diameter. Or if you want, you have to provide those numbers, right? 6.917. It's not 8 anymore. The thread is M81, this is not. So if you want, you have to fix this, okay? This phi is not 8 anymore. Okay, if I click on here, that's enough, by the way. When you say M81, then the machinist knows how much of drilling size he needs. So you don't need to provide the drill size for the hole. He knows it. He has these standard tables at his hand. Okay, so once you say M81, he knows. The only thing you need to provide for him is the depth of the thread and the depth of the hole. Those are the important things, because here you only provide pitch and diameter for the thread, not the depth. So if you want, you can go here and say, hey, this one is, by the way, 10 mil deep. Now he knows how far he should thread, right? Now he knows the depth of the thread. And then you can also provide the depth of the hole, right? You can provide the depth of the hole in this case, and for that, as I said, you can either show it on this hidden line, which is not a good idea, or you can do a section view. But in this case, I just show it on the hidden line for you, so you can provide the depth of this hole here, right? Something like that. Change this back to millimeters and put the bigger dimension further away so that they don't intersect. And again, if this guy is 2 of that, you can also use TYP. I don't use 2 times because this is M8 times. It might be confusing. This, exceptionally here, I use the keyword typical. Okay, so both of them are like that. So hopefully you see what I'm doing, right? I'm showing you all different scenarios for threaded hole, for machine hole, for everything, cut extrude, and so on and so forth. Okay, in one of my future draftings, I guess that's where I showed the threaded hole, and the reason is I wanted to show a cut section view for it. Yes, so that's why I mentioned it here. So what I can do is I also copy this slide into this lecture as well. It's good that it is in both locations, right? So you can see them. What else do we have? The next 2 things we have are inclined surface and dimensioning chamfers, which we have to talk about, dimensioning keyways, dimensioning grids, and using balloons for assembly, and finally auto dimension. So you see, although this is one lecture, I'm now passing 2 hours because, as I said, drafting lectures are very long. There are a ton of info that you have to learn. So let me show you inclined surface and chamfer very fast. So hopefully this example was good enough and informative enough. And I close this, go ahead very fast and create a very simple part for you and create the drafting for it. I'm not going to complete it, I just want to show you inclined surface and chamfer. which are, by the way, the same thing almost, but chamfers are just small inclined surfaces meant to reduce the sharpness of an edge, while inclined surfaces can be as big as you want. So here I provide a chamfer to this edge, and I make it like 5 mil and 45 degrees, something like that. Yes. Then I go and create a drafting, create the 3 views. I don't want isometric, as I said, this is just for fast to show you what to do. And select the front plane and bring them all here. And now I want to provide the dimension for this chamfered surface, chamfered edge here. So if it's a chamfered edge, you have to provide both the rise or run and also what? The angle of the chamfer, or you just provide both rise and run, length. So you say how much it horizontally cut and vertically cut. We call them rise and run, okay? There is a term for them, rise and run. So we can use those, or you can use one of them and the angle of the chamfer. But you show both of those numbers in one leader, despite inclined surfaces. If you have an inclined surface, it's a big inclined surface, it's not a chamfer, you use 2 different dimensions. Okay, as I said, you show rise and run, or you show rise or run and the angle, but you use 2 different dimension lines to show them. While if it's a chamfer, you show both of them in a single leader, and between them you use a what? You use a cross to show that this is a chamfer, this is not an inclined surface. So in this case, let me first make an inclined surface. Let's make this really big, so it more represents an inclined surface instead of a chamfer. Let's make it 20 and maybe 30 degrees, even bigger. Let's make it 30 and 60 degrees. That resembles more of an inclined surface, right? And go back here and update. So now if I call this an inclined surface, when I click on the dimension and I click on this, I'm not going to show diagonal. That's another important thing. When you are showing a chamfer or an inclined surface, do not use diagonal. You see this tool palette here? It is asking you what is it that you want. Do you want projected dimensions? Do you want rise, run, or what? You can use, say, yeah, I want projected. Align X, and then I can also project it along Y and change both of these guys to mil. Right? So this is one way to show it, using rise and run. Or instead of rise and run, you can show one of them, and then the other one you show the angle. So use the angle constraint, and you show the angle between these two. Okay, or you can bring it on this side if it allows to. Let's see, you can use angle sector and bring it to sector 1. No, I guess we have to go to sector 2. Yes. Okay, you can do it this way. So this is for what? For inclined surface. Now, on the other hand, as I said, if this is really a chamfer, a small thing that is meant to just get rid of a sharp edge like that, then you're not going to do this. Look, you're not going to do that. Instead, use the Chamfer tool, which is this guy itself, and all you need is you just click on the edge. And then here, the tool palette again allows you, do you want angle, or do you want what? Length angle. And you click on it, and that's it. Done. Okay? So, that's the difference between an inclined surface and a chamfer. Now, if you have a keyway, I guess I mentioned keys and keyways. If I haven't, I mentioned it here. So when you attach a part to a shaft that is rotating with it, right? So you want to attach a part to a shaft and they both rotate together. There are several ways to do it. One way is use the press fit. So you make the shaft actually a little bigger than the hole. It's called a press fit or interference fit, which we'll see in the next lecture. And then you apply some heat to the hole to make it bigger, and you apply low temperature to the shaft to make it squeeze or make it shrink a little bit. Then use pressure, and force the shaft into the hole. And when the temperature goes away and they go back to their normal size, so the shaft gets bigger, the hole gets smaller. Now those two guys are basically pressed against each other internally and they won't get separated, so they can rotate together. That's one way. The other way is, if you can see here, this hatch member is the shaft. This other looks like the inner of the ring. What you do is you cut, as you can see here, a small keyway, small slot into the shaft and a similar one onto the gear. Right? Let's see if I can make this bigger for you to see. So you see there is one here, there is one here, and then between these two slots you insert a simple cubic part, or if they are cylindrical, you insert like a cylinder, a rod. So not all keys are square like this. And then that key will keep these two parts attached to each other. When you want to provide dimensions for the key, what you need is the simple dimensions. If it's what? If it's a rectangular key like this, you provide basically the height, the width, and if the corners are filleted, you provide the radius of the fillet. And if you want to provide the dimensions for the shaft, of course you need diameter of the shaft, but then you also need what? The diameter minus the depth of the keyhole or keyway and the size of the keyway, right? Which is the difference between these two. Okay, so that's one when you do for keyways. So I just wanted you to know key and keyways, okay? And again, I can show you a video of that too, or key and keyway gear shaft. Just wanted you to understand that a little better. So this is a good thing, right? Again, this is a key seat or keyway. That's a keyway, that's a key, and it attaches these three parts together. And not all keys are square keys. There are other types of keys too, with different shapes, and key will keep rotating parts here. Key will keep rotating parts together, right? So that's an important thing. Okay, if you have a grid, if you have an SP line, and this SP line is passing through a bunch of key points, like 1 to 12, how you would provide dimensions for this SP line? So you cannot dimension the SP line, but you can provide the dimensions or the locations actually for the major points 1 to 12. But if I want to provide, let's say I put my origin here. If I want to provide what? The X and Y offset of 0.1 with respect to origin, 0.2 with respect to origin, 3, 4, all the way to 12. You expect me to have what? A ton of extensions and dimension lines all over here. And this is going to be super crowded, especially if you have more points, right? You barely can see the SP line itself. There are tons of dimensions lines and extension lines crossing each other to show the offsets with respect to origin. Instead of that, you use a table. You set a location for the origin and then provide the X and Y coordinates of these points with respect to origin all in a table, and you avoid all of those dimensions and extensions. This makes your drafting a ton cleaner. Okay, so you can use a table, right? And let me show you that right now. So if I create a sheet 2, and on sheet 2 I create some spline, like this. So it has six points. First, I'm gonna number these points. So when I say point 1, I know what I'm talking about. So I come here, click on the text, click on this point, and call it point 1. Yes. And then I repeat the same thing for these guys. Point 2. I can make the sizes bigger if I want to. And then maybe click here, call this 3, right? And so on and so forth. And then I can set my origin somewhere, anywhere that I want, right? So I can set my origin here, and then I insert a table, which is this guy, and I say I want, let's say it's 6 columns, so I need 7 and 3, and I insert it here, and here I say point number, right? And then here I say X, and here I say Y. Yes, and I can of course always make this guy bigger if I want to, and then I can provide text here, so I can call this X. Right, and I can call this one Y, and then when I know these numbers I can measure them, but I'm not gonna write them. So if I know this distance between 2 and 1 in the vertical direction, that's that much, right? Or in millimeters, it is what? 30 that much, and then in the X direction it is this guy, right? So I come here and I say point number 2. I can say point 1 is origin, right? So I say point 1 is origin, so X is 0, Y is 0. And then point 2 has X equal to 30.08 and Y equals, or actually Y equals 34.08 and X equals 45.44. Right? And then fill the table. So this is a better, much more efficient way to dimension splines instead of just fill your drafting with a ton of dimensions, right? Because as I said, then you have to do it for this one, right? And then you have to do it for this one. You see, and then you have to do it for others, and you're gonna get tons of these guys. So I don't need any of them now. I don't need it. All I need is this spline numbering and a table, and that would take care of everything for me. So this is more efficient. The last two things are, one, if you have an assembly and I ask you to provide the isometric of the assembly, how would you do it? Or the isometric of the exploded assembly, how would you do it? And then name the parts with balloon in it. So let's talk a little bit about drafting of assemblies. Okay, and finally I talk a little bit about this cheating tool. So if you have an assembly, when you have an assembly, let me see if I can delete these guys. Whenever you have an assembly, not only you have to create the drafting for individual components, you also need to create what? Drafting for the entire assembly, right? That is your project number 2. So if your assembly has 5 parts, you need 6 drafts. 5 for the parts, 1 for the entire assembly. So you need 6 sheets. So here, let's say I go ahead and I open an assembly that I have from the past, which is actually your project number 2. So this is your project number 2. You have to create a drafting for this, for both of the parts and then for the assembly, right? And I want to create a drafting for this. So I open the assembly, then I go to drawing, I go to view creation wizard and bring in all these views and bring in an isometric view, finish, go here, select the front view and bring them all in, right? Like this. Okay, so I need that as well as the 2 individuals. Now, sometimes I ask you to, on the isometric of the assembly, name each one of the parts with a balloon. Show each one of them, name them with a balloon so that the person knows this is part 1, that is part 2, this is the back part, this is the front part, or so on. How would you do that? And sometimes I say bring the assembly, but the isometric of the assembly, I want it in exploded mode, not in the assembled mode. So I don't want this guy to be in what? I don't want this to be in the assembled version. I want it in exploded assembly. So how can I do that? Is there any way? I cannot explode this view here. I have to do it already in the assembly, then bring the drafting here. So let me show you. Let's say I want an assembly exploded only. So before I do anything, I come here and explode this. Then when I go back and say I want an assembly view only, maybe, right? So I go here and I want only an assembly view. And then I choose a front plane. And now look. Yes? So this is how you would get an assembly exploded. And if you want, you can cut this and bring it back here. Yes? And you can get rid of this if you don't like it. So I can do that, and then I say, okay, call this back part, call this front part, and show that with the balloon. Where is the balloon? So they're under text, and this is the balloon. So you click on the balloon, click on the part, bring it out, and then give it a name. So I call this back part. Okay? And if you don't like the font size, change it. Then I repeat that. I click on this one, bring it out, and I call this the front parts because each part has a name, right? So if in your homework or your quiz or exam or anything, I say create the draft of the exploded assembly and name the parts with balloons, that's what I mean. Okay, so hopefully you got that. Finally, there is a small cheating tool which is not good. It's called auto dimension tool in drafting, which tries to apply the dimensions to the views from the dimensions you made on the 3D part. So it tries to import them from 3D part also in the drafting. It's not perfect, it never works perfect, and when it brings them, the color of the imported dimensions are in green instead of black. So I show you how you can change the color of those greens back to black, and I mention also why this tool is not a perfect tool. So let me show you that. So this is what we do. Let me close this. No. Let me open one of these parts, or maybe the input link, doesn't matter. Let me get the input link. And this is good actually. Let's work with this one. So I create a drafting for this, and you know I have provided some dimensions to this, so it has dimensions. It's fully defined actually. So I create my 3 views for this object. Right, like that. And then instead of me going and using the dimension tool one by one, adding them, I use the cheat tool, which is this guy here, auto dimension. It says, hey, could you import them from the 3D object? And it says, what do you want? And I said, bring the generated constraints in the 3D. And it says, sure. And you do that, and look at what you get. That's all you get. 2 dimensions. It does not bring everything. And should I provide this dimension like that, or should I provide the radius? Of course, that number is the radius of this arc. So instead of showing that gap like this, I should show a radius. This is good, but not that one. So the problem with this is, not always it gives you all the dimensions. Second, some of the dimensions it show it in a non-standard way. And third, sometimes it brings redundant dimensions, so it shows some dimensions several times. Let me use 2D as well, although it's not going to change anything. So sometimes it shows redundant dimension, and sometimes it puts some of the dimensions inside. So what you need to do is, after it provided some of the dimensions, you have to now go and do a lot of cleaning. It's like when you're writing a computer code, right? So is it easier to go and use somebody else's code that is so poorly written with so many errors and problems and debug it and clean it and use it? Or if you know how to do it well yourself, you write the code yourself, your own code, and not first trying to understand somebody else's code, clean it, debug it, and modify it. I personally prefer to start from scratch. But if for any reason you want to use some of these dimensions, do not leave their color in green. For 2 reasons. First of all, the standard is we use black for the color of all dimension tools. Second, when you print green, especially when you print in black and white, it barely shows itself. Green is one of the colors when you print in black and white, you can barely see it. So don't leave it in green. And you might wonder, can I change them to black? Yes. You go to Tools, and then you go to Options. And if you go to Mechanical Design Drafting, okay, so you go to Dimensions, and then you come here to Types and Colors. And you see here it says dimensions generated from 3D, they are green. You say, no, I want them black. Okay, and they go black like this. But again, I don't recommend, that's why I left it for the last. Don't use this tool too much, okay? You don't learn and get insight, and it does a very sloppy job.